All right, so in this problem, the problem says that we're using a bomb calorimeter to do some energy readings here. And it's giving us the mass of the different reactants that we're using in the problem. And in the end, is asking us to calculate the energy in kilojoules per mole of sodium bicarbonate. All right, so we're using the exact same reaction equation from question number 9 here. So we've already got our balanced equation in this case. All right, so since we're using a bomb calorimeter, all right, let's go ahead and start off by writing the equation for a bomb calorimeter. So Q, our heat, is equal to the heat capacity of the calorimeter times delta T. All right, in this case, delta T is going to be the final temperature minus the initial temperature. All right, so we have our the heat capacity is given us to us in the equation, and our temperature change is given as well. So if we multiply these two together, we're going to end up with minus 180.6 kilojoules of energy. All right, here, because of the confusion with delta T, it's a good idea to check the sign on our energy. All right, so in this case, we're saying that the temperature of the calorimeter is increasing, right? All right, so in order for it to increase, our reaction, which is in the bomb part of the calorimeter, has to be giving off energy. It has to be giving energy to the calorimeter itself, right? So the energy for our reaction then has to be negative, right? Because our reaction doesn't like to lose energy. Okay, so we have our energy that's actually being given off by our sample. So now we need to figure out the number of moles that we have, because we need our answer to be kilojoules per mole. All right, so we have the kilojoules part here. All right, so what we need to do is we need to figure out what is the limiting reagent. All right, so we start off with our 122 grams of hydrogen iodide and our 25 grams of sodium bicarbonate, and we do some math here. And we end up with 0.953 moles of hydrogen iodide and 0.298 moles of sodium bicarbonate. So we can take one of them, take the hydrogen iodide, convert it to moles of sodium bicarbonate. So there's 1 hydrogen iodide per 1 sodium carbonate. And so we need 0.953 moles of sodium bicarbonate. But we only have 0.298 moles of sodium bicarbonate. All right. So that means that sodium bicarbonate is our limiting reactant. Right? Because of this, we can say that therefore all of that sodium bicarbonate is going to react. All right, so that if it's a limiting reactant, that means it's all going to have to react. All right, so now what we can do is we can take our minus 180 kilojoules and divide it by the number of moles of sodium bicarbonate that are going to react here. All right, so we're asked to report it in terms of moles of sodium bicarbonate. Thankfully, in this case, the sodium bicarbonate is the limiting reactant, so we can use this number of moles. And we end up with this energy here, minus 606 kilojoules per mole of sodium bicarbonate. And just as a little side note, you may notice that energy is completely different than the energy in the last question. That's just because I didn't bother to do some math. So don't think anything into that.